Close your eyes for a moment. Take a slow, deep breath in and let it out. Feel the weight of your body sinking gently into your bed. The world outside is quiet tonight. And tonight, we are going on the longest journey ever imagined. A journey not across miles, but across time itself. Trillions and trillions of years into the future, to a place where the last light in all of existence slowly, quietly, peacefully fades away. There is nothing to worry about tonight, nothing to think about. Just this story, just your breath, just the gentle darkness of space stretching out before you, infinite and calm. Right now, as you lie here in the quiet dark of your room, the universe above you is unimaginably full. If you could float up through your ceiling, through the atmosphere, past the moon, past the sun, out beyond our little solar system and into the vast open arms of the cosmos, you would find yourself surrounded by light. So much light. Scientists tell us that there are approximately 2 trillion galaxies scattered across the observable universe. 2 trillion. Each one a massive, slowly spinning island of stars, gas, dust, and mystery. And within each of those galaxies, there are hundreds of billions of individual stars, each one burning, glowing, pulsing with ancient nuclear fire. The numbers are so large that the human mind cannot truly hold them, but you do not need to hold them tonight. You only need to breathe and let them wash over you like a warm, quiet tide. The universe right now is full of life, full of light, full of energy beyond measure. Stars being born, stars slowly dying, the great cosmic cycle turning slowly, endlessly, like a wheel so large that no one has ever seen its edges. And somewhere in the middle of all of this, on a tiny blue planet orbiting an ordinary yellow star, you are lying in your bed, warm and safe, listening to the universe breathe. Among those hundreds of billions of stars in our galaxy alone, there is one that matters most to you. One that you have seen every single day of your life without perhaps ever truly thinking about what it is. Our sun. That warm golden presence that rises each morning and sets each evening, painting the sky in colors of orange and pink and deep violet. Our sun is what scientists call a yellow dwarf star. It sounds almost humble, doesn't it? A dwarf. But do not let that name fool you. Our sun is so large that 1 million Earths could fit inside it with room to spare. It is a nuclear furnace of almost incomprehensible power, fusing hydrogen atoms into helium at its core every single second, releasing energy that travels 93 million miles through empty space and arrives at your window as warm afternoon light. Right now, our sun is 4.6 billion years old. It has been burning for longer than the Earth has existed, longer than the oceans formed, longer than the first living cell ever divided. And yet, in the grand scale of cosmic time, our sun is middle-aged. It is not young, but it is nowhere near old. It sits comfortably in the middle of its long, slow life, steady and warm and reliable as it has always been. As you breathe in and out right now, the sun is on the other side of the world, quietly doing what it has always done, burning, waiting, keeping the darkness away. The universe itself is 13.8 billion years old. 13.8 billion years. Say that slowly in your mind and feel how strange it sounds. Billion. 13 of them. And yet, as impossibly old as that seems to us, to creatures who measure our lives in decades, the universe is actually very, very young. Cosmologists, the scientists who study the large-scale structure and timeline of everything that exists, tell us that the universe has barely even begun. If you compressed the entire lifespan of the universe into a single calendar year, today, right now, this very moment as you lie in your bed, would be sometime in the very early days of January. The universe has the equivalent of 11 and a half more months to go. 11 and a half months of stars burning, galaxies colliding, black holes slowly consuming, and the fabric of space itself quietly stretching outward in all directions. We are not at the middle of the story. We are not near the end. We are at the very, very beginning. And there is something deeply comforting about that, if you let yourself feel it. The universe is young. The story is just starting. And tonight, you are part of it. A small, warm, breathing part of the greatest story ever told, lying peacefully in the early chapters of a book that will not end for longer than any mind can comprehend. Stars do not simply appear. They are not switched on like lights. They are born slowly, the way all beautiful things are born, through time and pressure and patience. Scattered throughout every galaxy in the universe are vast clouds of hydrogen gas and dust. These clouds are called nebulae, and they are among the most beautiful structures in all of existence. Enormous, soft, colorful curtains of gas drifting silently through space, sometimes stretching across hundreds of light years. For millions of years, these clouds simply float. They are not doing anything dramatic. They are simply existing, swirling gently, waiting. But gravity is always patient. Slowly, over millions of years, gravity begins to pull regions of these clouds together. The gas gets denser, the pressure builds, the temperature at the center begins to rise. And then, at a precise, magical moment, the temperature and pressure at the core of this collapsing cloud reaches a critical point, 10 million degrees Celsius, and something extraordinary happens. Hydrogen atoms, which normally repel each other, are pressed so tightly together that they fuse. They become helium. And in that fusion, an enormous burst of energy is released. Light, heat, radiation. And just like that, in the darkness of space, a new star is born. A tiny point of light that was not there before. This is how every star you have ever seen came to exist, including our sun, born from a cloud of gas, through the slow, patient work of gravity, into a burning point of light that will shine for billions of years. As you close your eyes right now, somewhere in the universe, another star is being born. Another light is switching on in the darkness. Right now, as we drift together through the story of the universe, new stars are still being born. Every single second, approximately 3 new stars come into existence somewhere in the cosmos. 3 new suns igniting in the darkness, beginning their long, slow journey of burning and shining and eventually fading. It sounds like a lot, and it is. But here is something that scientists have discovered that is both fascinating and quietly melancholy. The rate at which new stars are being born is slowing down. It has been slowing down for a very long time. The universe is not creating stars as quickly as it once did, and it will continue to slow down more and more as billions of years pass. Think of it like a great river that was once rushing and powerful, full of energy and movement. The river is still flowing, still beautiful, still alive, but it has slowed. The current is gentler now. The water moves with less urgency. This is the universe we live in today. Still creating stars, still full of light and energy, but slowly, imperceptibly settling into a quieter rhythm. 3 stars per second sounds like abundance, and it is, but billions of years from now, that number will be 2 per second, then 1 per year, then 1 per century, and then, after an almost incomprehensible span of time, the last star will form, and no new ones will follow. But that time is so far away that tonight, lying here in your bed, you can rest in the knowledge that the universe is still very much alive, still breathing, still creating. If you could travel back in time, not just hundreds or thousands of years, but billions of years, you would arrive in a universe that looked almost nothing like the one we know today. 10 billion years ago, the universe was a very different place. It was younger, denser, hotter, and absolutely blazing with the light of new stars being born at a rate that makes today seem almost sleepy by comparison. Scientists call this period the cosmic noon, the peak of star formation in the universe's history. During this golden era, galaxies were colliding with each other constantly, and those collisions were compressing vast clouds of gas, triggering explosions of starbirth on a scale that has never been repeated since. The universe was louder then, brighter, more chaotic, more alive in a raw, urgent way. But even the most energetic periods must eventually settle. After cosmic noon, the rate of star formation began its long, slow decline. The great collisions became less frequent. The gas clouds were gradually used up. The universe began to quiet down. And over the next 10 billion years, right up to today, to this very moment as you breathe slowly in your bed, the universe has been settling. Not dying, not ending, simply settling, the way all things settle after a great burst of energy, the way you settle into your pillow at the end of a long day. The universe, in its own way, is learning to rest. Not all stars are created equal. The universe has stars of many different sizes, from tiny, dim red dwarfs barely larger than a planet to enormous blue giants hundreds of times more massive than our sun. And here is one of the universe's most beautiful ironies. The larger and more powerful a star is, the shorter its life will be. A massive star, one that is perhaps 50 or 100 times the mass of our sun, burns so intensely and so hungrily that it exhausts its hydrogen fuel in just a few million years. To a star, a few million years is barely a moment. These great blazing giants live fast and die young, ending their lives in one of the most spectacular events in all of nature, a supernova. A supernova is an explosion of such incredible power that for a brief moment, a single dying star can outshine an entire galaxy of hundreds of billions of other stars. It is the universe's most dramatic farewell. The dying star releases more energy in that single explosion than our sun will release in its entire 10 billion year lifetime. And then, it is gone. What remains is either a neutron star, a city-sized object of almost unimaginable density, or a black hole, a place where gravity has become so strong that not even light can escape. The most powerful stars leave the most dramatic marks. And then, silence. In the place where a blazing giant once burned, there is only a slowly expanding cloud of gas and the quiet remnant of what used to be the most brilliant thing for light years in every direction. And then there are the small ones, the humble ones, the stars that do not blaze or explode or announce themselves dramatically. Red dwarf stars are the smallest, dimmest, coolest type of star in the universe, and they are by far the most common. If you gathered together every star in the Milky Way, approximately 70% of them would be red dwarfs. They are everywhere, these small, quiet stars, burning so gently and so efficiently that they will still be shining long after every other type of star has gone dark. A red dwarf burns its hydrogen so slowly, so carefully, so patiently that it can live for 10 trillion years. 10 trillion! Our universe is only 13.8 billion years old, which means that not a single red dwarf star that has ever formed has yet died of old age. Every red dwarf that has ever ignited is still burning right now. They are the tortoises of the cosmos, slow, steady, almost impossibly patient. And when the last massive stars have exploded, when the stars like our sun have swelled into red giants and then collapsed into white dwarfs, the red dwarfs will still be there. Dim and quiet, barely visible even up close, but burning, still burning. For trillions of years after everything else has gone dark, these small, patient stars will continue their slow, steady work. They are the last keepers of the light, the final guardians of the stelliferous era, the age of stars. There is something beautiful happening every time a star dies, something that the universe has been doing since the very beginning, a kind of cosmic recycling that connects every star that has ever burned to every star that will ever burn. When a star reaches the end of its life, whether it ends quietly as a white dwarf or dramatically as a supernova, it does not simply vanish, it releases its material back into space. All of the atoms it spent its lifetime fusing together, helium, carbon, oxygen, iron, gold, and dozens of other elements, are scattered outward into the surrounding space like seeds thrown into the wind. These atoms drift through space for millions of years, mixing with other clouds of gas and dust, and then, slowly, gravity begins its patient work again. The clouds compress, the pressure builds, and new stars are born, new stars made partly from the material of old dead stars. Every star in the universe today contains atoms that were forged inside stars that no longer exist. Our sun contains the remnants of stars that died billions of years before it was born, and the planets orbiting our sun, including Earth, are made of this same recycled stellar material. You, lying there in your bed right now, breathing slowly and peacefully, you are made of atoms that were forged inside ancient stars, scattered across space when those stars died, and eventually assembled over billions of years into you. You are not separate from the stars. You are made of them. 5 billion years from now, a span of time so vast that it makes the entire history of human civilization look like a single heartbeat, our sun will begin to change. It will have spent the last 10 billion years of its life steadily fusing hydrogen into helium at its core, burning with the quiet reliability that has made life on Earth possible. But eventually, the hydrogen in the sun's core will begin to run out, and when that happens, the sun will do something that sounds alarming, but is actually simply the next step in a star's long, slow journey. It will expand. Slowly at first, then more and more dramatically, the outer layers of the sun will begin to swell outward. The sun will grow larger, much, much larger, becoming what astronomers call a red giant. Over millions of years, it will expand until it has swallowed Mercury, then Venus, and eventually, in all likelihood, Earth itself, our small blue home, the only world we have ever known, will be absorbed into the outer atmosphere of a dying star. But by that point, 5 billion years from now, the story of life on Earth will have been over for a very long time. The oceans will have boiled away in about 1 billion years, long before the red giant phase. This is not a tragedy. It is simply the life cycle of a star, playing out exactly as it always has, exactly as it always will. As you breathe slowly tonight, your sun is steady. It is warm and reliable, and will remain so for longer than the human mind can truly imagine. After the sun passes through its red giant phase, after it has swelled and brightened and then gently shed its outer layers into a beautiful expanding shell of glowing gas called a planetary nebula, what remains at the center will be something small, dense, and quietly extraordinary: a white dwarf. A white dwarf is the collapsed core of a dead star. In the case of our sun, this white dwarf will be roughly the size of Earth, but it will contain roughly half the mass of the sun as it is today. It will be extraordinarily dense, extraordinarily hot when it first forms, glowing with a fierce white light, but it will have no fuel left to burn. It is not a star anymore. It is simply a remnant, an ember, slowly cooling in the darkness of space. Over billions of years, this white dwarf will radiate its heat away into the surrounding darkness, growing slowly cooler and dimmer. From white, it will fade to yellow, then orange, then red, and eventually, after billions upon billions of years, it will cool completely, becoming a cold, dark, inert sphere drifting silently through space, invisible in the darkness. This is called a black dwarf. And here's something remarkable. The universe is not yet old enough for any black dwarfs to exist, not a single one. Every white dwarf that has ever formed is still glowing, still warm, still cooling. They are all still in the process of their long, slow fade. The universe is so young that even its dead stars still carry warmth. A black dwarf is perhaps the quietest object in the universe, not dramatic like a supernova, not mysterious like a black hole, simply cold, simply dark. Simply still. It is what a white dwarf becomes after it has spent so many billions of years radiating its heat away into space that there is no warmth left at all. No light. No energy. Just a small, dense, dark sphere drifting silently through a universe that has grown very, very old around it. As we mentioned, the universe is not yet old enough for black dwarfs to exist. The time it takes for a white dwarf to cool completely is longer than the current age of the universe. So every white dwarf out there is still, in some sense, alive, still glowing, however faintly. But in the far future, when the universe has aged for quadrillions of years, the white dwarfs will finally finish their long cooling process. One by one, they will go dark, like embers in a fireplace, glowing orange, then red, then losing their color entirely and becoming simply warm to the touch, and then cool, and then cold. Black dwarfs will drift through the darkness of an old, quiet universe, silent monuments to stars that once burned. As you lie here tonight, breathing slowly, it is comforting to know that this cooling is so slow, so gentle, so patient. The universe does not rush. It lets its stars fade slowly, with dignity, over timescales that dwarf even the most generous human imagination. Everything in the universe that we love about the night sky, the stars, the galaxies, the glowing nebulae, the Milky River of our own galaxy stretching across a dark summer sky, all of it depends on one thing: hydrogen. Simple, humble hydrogen, the most abundant element in the universe. The first element to form after the Big Bang. One proton, one electron, endlessly repeating across the cosmos. Stars are, at their most fundamental level, hydrogen-burning machines. They take hydrogen, crush it together with gravity, fuse it into helium, and release the energy of that fusion as light and heat. Every photon of sunlight that has ever touched your skin was born from a hydrogen atom being fused into helium deep inside the sun's core. But hydrogen, for all its abundance, is not infinite. The universe was born with a finite supply of it, and with every star that burns, with every nuclear reaction happening in every stellar core across the cosmos, that supply is slowly being used up. Hydrogen is being converted into helium, and helium into heavier elements, and those heavier elements do not easily convert back. The universe is slowly, imperceptibly running out of the fuel it needs to make stars. This process will take a very, very long time, hundreds of trillions of years, but it is happening. Right now, as you breathe, the universe's hydrogen is being used. Stars are burning, and the great fuel tank of the cosmos is ever so slowly emptying. Inside the core of every star, right now, a transformation is taking place that has been happening since the first stars lit up the universe over 13 billion years ago. Hydrogen atoms, the simplest atoms in existence, consisting of just a single proton and a single electron, are being crushed together by the immense gravity of the star around them until they fuse. Two hydrogen atoms fuse to begin a chain reaction, then another and another. The end product of this chain of reactions is a helium atom, slightly heavier than the hydrogen that went into it, but not quite as heavy as the two hydrogen atoms combined. That tiny difference in mass, that small amount of matter that seems to simply disappear, is converted directly into energy, according to Einstein's famous equation. And that energy is what we see as starlight. Every star in the night sky is shining because hydrogen is becoming helium inside it. And that helium, that product of fusion, accumulates at the star's core. It is a byproduct, a remnant, the ash of stellar burning. And unlike hydrogen, helium cannot easily be used for the same fusion reactions. In most stars, it simply accumulates, building up in the core like ash in a fireplace, until the hydrogen around it is gone. The universe is converting its hydrogen into helium one star at a time, slowly but surely, and that helium will remain, unable to become stars again, long after the last star has burned. Galaxies are not just collections of stars. They are also filled with vast reservoirs of gas, mostly hydrogen, that float between the stars in great clouds, waiting to be pulled together by gravity and formed into new suns. This gas is the raw material of star formation. Without it, no new stars can be born. And over time, over billions and billions of years, galaxies use up this gas. Stars form from it, burn through their hydrogen, and when they die, they return some material to the galaxy. But not all of it. Some of the hydrogen is locked away forever in the cores of dead stars. Some is converted into heavier elements that cannot easily form new stars. With each generation of stars, the galaxy's gas supply grows a little smaller, a little more depleted. The Milky Way today still has enough gas to form stars for billions of years to come. But eventually, in the far, far future, the gas will be gone. The last clouds of hydrogen will have been consumed, the last new star will have formed, and the universe will transition into its next great chapter, the degenerate era, an age dominated not by burning stars, but by the cold remnants they leave behind, white dwarfs, neutron stars, the slow, patient darkness settling over a universe that once blazed with light. We are so deep inside the stelliferous era right now that its end is almost impossible to imagine. But it will come. After 100 trillion years of starlight, the universe will grow quiet. There is something beautiful happening every time a star dies. Something that the universe has been doing since the very beginning, a kind of cosmic recycling that connects every star that has ever burned to every star that will ever burn. When a star reaches the end of its life, whether it ends quietly as a white dwarf or dramatically as a supernova, it does not simply vanish, it releases its material back into space. All of the atoms it spent its lifetime fusing together, helium, carbon, oxygen, iron, gold, and dozens of other elements, are scattered outward into the surrounding space like seeds thrown into the wind. These atoms drift through space for millions of years, mixing with other clouds of gas and dust, and then, slowly, gravity begins its patient work again. The clouds compress, the pressure builds, and new stars are born, new stars made partly from the material of old dead stars. Every star in the universe today contains atoms that were forged inside stars that no longer exist. Our sun contains the remnants of stars that died billions of years before it was born, and the planets orbiting our sun, including Earth, are made of this same recycled stellar material. You, lying there in your bed right now, breathing slowly and peacefully, you are made of atoms that were forged inside ancient stars, scattered across space when those stars died, and eventually assembled over billions of years into you. You are not separate from the stars. You are made of them. 5 billion years from now, a span of time so vast that it makes the entire history of human civilization look like a single heartbeat, our sun will begin to change. It will have spent the last 10 billion years of its life steadily fusing hydrogen into helium at its core, burning with the quiet reliability that has made life on Earth possible. But eventually, the hydrogen in the sun's core will begin to run out, and when that happens, the sun will do something that sounds alarming, but is actually simply the next step in a star's long, slow journey. It will expand. Slowly at first, then more and more dramatically, the outer layers of the sun will begin to swell outward. The sun will grow larger, much, much larger, becoming what astronomers call a red giant. Over millions of years, it will expand until it has swallowed Mercury, then Venus, and eventually, in all likelihood, Earth itself, our small blue home, the only world we have ever known, will be absorbed into the outer atmosphere of a dying star. But by that point, 5 billion years from now, the story of life on Earth will have been over for a very long time. The oceans will have boiled away in about 1 billion years, long before the red giant phase. This is not a tragedy. It is simply the life cycle of a star, playing out exactly as it always has, exactly as it always will. As you breathe slowly tonight, your sun is steady. It is warm and reliable, and will remain so for longer than the human mind can truly imagine. But before the degenerate era fully takes hold, there will be a transitional time, a period that stretches across trillions of years when the universe is not yet fully dark. A time when, if you drifted through the cosmos, you would still see light. Not the blazing light of blue giants or the warm golden glow of sun-like stars. Just small, dim, reddish points of light, scattered across the darkness like dying embers. These are the red dwarfs, the last stars. As every other type of star reaches the end of its life and fades away, the red dwarfs will remain. Their extraordinary efficiency, their slow and patient burning will keep them alive long after everything else has gone dark. They will be the sole inheritors of the stelliferous universe, the last keepers of the age of stars. If any life exists around these red dwarfs in the far future, it will live in a universe that is very different from ours. A universe where the night sky is almost completely dark, where other stars are so far away that they are invisible to the naked eye, where the galaxy is a dim, sparse, quiet place compared to the blazing wonder it is today. But there will still be warmth, there will still be light, there will still be stars. For a few more trillion years, the red dwarfs will hold the darkness at bay, burning their slow and patient fires, keeping the age of stars alive just a little longer. Of all the stars we know, one has become something of a symbol for the quiet endurance of red dwarfs. Proxima Centauri, our nearest stellar neighbor, just 4.2 light-years away, is a red dwarf. It is so close to us, in cosmic terms, that if the Sun were a basketball, Proxima Centauri would be another basketball sitting about 4,000 miles away. And yet, for all its closeness, Proxima Centauri is invisible to the naked eye. It is simply too dim, too small, too quiet to be seen without a telescope. But it is there, burning steadily, patiently, and it will continue burning long after our sun has swelled into a red giant, shed its outer layers, and collapsed into a white dwarf. Scientists estimate that Proxima Centauri has enough hydrogen fuel to burn for approximately 4 trillion years. 4 trillion years from now, when our sun has been dead for longer than the current age of the universe, Proxima Centauri will still be burning, dim and red and quiet, but burning. It is a comforting thought, somehow, that our nearest neighbor is so patient, so enduring, that even as the universe grows older and darker around it, Proxima Centauri will hold its small, steady light. As you breathe slowly in the darkness of your room tonight, Proxima Centauri is out there, 4 light-years away, doing what it has always done, simply burning, simply existing, simply being a star. And then there will be one. After all the red dwarfs have one by one exhausted their hydrogen and faded into cold darkness, there will be a single star left, the last star in the universe. We cannot know exactly which star it will be. It will be whichever red dwarf happens to have been born with the most hydrogen, the most fuel, the most reserves to draw upon. But it will be there. A single, dim, reddish point of light in a universe that has otherwise gone completely dark. Imagine that. A universe so old, so vast, so far beyond anything we can truly comprehend, and in all of that darkness, in all of that empty space stretching for billions of light years in every direction, one small red star still burning. It will be alone in a way that is almost impossible to imagine. No neighboring stars, no glowing nebulae, no spiral galaxies lit from within by millions of suns. Just space. Empty, cold, silent space, stretching outward forever. The galaxies will still exist as gravitational structures, the dark remnants of what they once were, but they will be invisible. Dark matter and black holes and cold stellar remnants orbiting together in the dark, but producing no light, no warmth, nothing to see. The last star will have no way of knowing it is the last. It has no consciousness, no awareness of the universe around it. It simply burns, as stars have always burned, doing what stars do, converting hydrogen into helium, releasing energy, shining into the darkness. But the darkness around it will be absolute, and the silence will be total. In all the universe, across all of space, this one small red star will be the only source of light and heat, the final heartbeat of the stelliferous era, the last warm thing in a universe that is growing colder by the second. As you lie in your bed tonight, surrounded by the warmth of your home and the quiet sounds of the world outside, let yourself feel grateful for the abundance of this moment. We live in a universe of 2 trillion galaxies and countless stars. We are swimming in light. Even if the last star burns for trillions of years, it will burn alone. Not just without other stars, but without life. The conditions for life as we know it require more than just a star. They require planets with the right chemistry, the right temperatures, the right mix of elements. They require liquid water and stable orbits, and the delicate balance of forces that allowed life to emerge on Earth. By the time the last star is burning, the universe will have long since passed through all of these conditions. Any planets that formed around the last star would be ancient beyond imagining, frozen, airless, geologically dead. The elements needed for complex chemistry will still exist, scattered as they are through the cosmos, but the conditions to bring them together into something living will be gone. And so the last star will burn in a universe that is, for the first time since life first appeared, completely without life. No minds to observe it, no eyes to see its dim red light, no hearts to feel wonder at its existence. Just the star itself, burning alone in the vast and silent dark. There is something deeply moving about this, if you let yourself feel it. We are here, right now, in one of the brief and precious moments in cosmic history when the universe is full of life. When there are minds to look up at the stars and feel wonder, when there are people lying in beds at night listening to stories about the cosmos, feeling small and warm and alive. This moment, this era is extraordinary, and it will not last forever. After its final reserves of hydrogen are exhausted, after trillions of years of patient burning, the last star will begin to fade. Not with a bang, not with a supernova. Red dwarfs do not end dramatically. They simply dim. Slowly, over millions of years, the last star's light will grow weaker. Its color will shift, from dim red to something dimmer still. The nuclear reactions in its core will slow and slow and slow, like a fire running out of wood. Not going out all at once, but guttering, flickering, losing its intensity by degrees. And then, one final moment, though no one will be there to mark it, no clock will record it, no mind will witness it. The last star will go out. The last photon of starlight will travel outward into the darkness, and the stelliferous era, the age of stars, 100 trillion years of light and warmth and nuclear fire, will be over. The universe will be dark. For the first time since the first stars ignited hundreds of millions of years after the Big Bang, there will be no starlight anywhere in the cosmos. Just the cold remnants of dead stars drifting in the dark. Black holes slowly evaporating, and the vast, silent, empty stretches of space between them. As you feel yourself drifting towards sleep right now, imagine that last fading light, gentle, quiet, peaceful, not a violent end, but a soft one, the way a candle flame shrinks and dims and then simply isn't there anymore. With the last star gone, the universe enters its longest and most silent chapter, a period so vast that even the word era seems inadequate. Scientists call it the dark era, and dark it will be. In the dark era, there are no stars, no galaxies glowing with starlight, no supernovae blazing in the distance. The universe will be filled with black holes of various sizes, cold stellar remnants, neutron stars and black dwarfs, and the vast emptiness of space, growing ever colder as the universe continues to expand. The temperature of the universe will approach absolute zero, the coldest possible temperature, where all molecular motion ceases. Not quite absolute zero, never quite, but closer and closer to it as the eons pass. The universe will be extraordinarily still, extraordinarily cold, and yet, even in the dark era, things will still be happening. Black holes will still be slowly consuming whatever drifts near them. The remnants of dead stars will still be orbiting each other in the shells of what were once galaxies. And all around, permeating everything, a faint quantum phenomenon described by Stephen Hawking will be at work, slowly, over unimaginable timescales, causing even the black holes to evaporate. The dark era is not nothing, it is simply the universe at rest, deeply, profoundly, almost infinitely at rest. And there is something peaceful about that, a universe that has done its work, burned its stars, and now simply exists in quiet darkness. Black holes seem permanent, eternal, indestructible. They consume everything that comes near them, crushing matter and energy into a singularity from which nothing, not even light, can escape. But Stephen Hawking discovered something remarkable about black holes, something that nobody expected. They are not truly permanent. They evaporate. Through a quantum mechanical process now called Hawking radiation, black holes very, very slowly emit tiny amounts of energy over time. This happens because of quantum effects at the event horizon, the boundary of the black hole, where pairs of particles are constantly appearing out of the vacuum of space. Occasionally, one of these particles falls into the black hole and one escapes. The escaping particle carries a tiny amount of energy away with it, and over an incomprehensibly long time, this process causes the black hole to lose mass, very slowly, very gradually, until eventually it is completely gone. For a small black hole, this evaporation might take only a few 100 billion years, but for the supermassive black holes that sit at the centers of galaxies, objects billions of times more massive than our Sun, the evaporation process takes far, far longer. A supermassive black hole might take 10 to the power of 100 years to evaporate, a number so large it defeats imagination entirely. But it will happen. Every black hole will eventually evaporate, even the largest, even the most ancient. Time, it turns out, is the one thing that can defeat even a black hole.
Just as there will be a last star, there will also be a last black hole. The largest, most massive black hole in the universe, the one with the most matter to slowly radiate away, will be the final one to evaporate. It will be ancient beyond all measure. The universe around it will have been dark for longer than the current age of the universe raised to unimaginable powers. The temperature of the surrounding space will be almost indistinguishable from absolute zero. There will be nothing left in the cosmos. No stars, no planets, no neutron stars, no smaller black holes. Just this one final gravitational giant, slowly, almost imperceptibly losing mass, radiating the faintest possible whisper of energy into the surrounding void. And then it too will be gone. The last black hole will evaporate in a final burst of Hawking radiation, a tiny flash of energy in a universe that has been dark for so long that the age of stars is a memory so ancient it might as well have never existed. And then there will be nothing. No matter, no energy concentrated anywhere, no structure of any kind. Just space, flat, cold, uniform, expanding, and the faintest possible background of diffuse radiation spread so thinly across so much space that it has no meaning, no pattern, no purpose. The universe will be, for the first time, truly empty. The final state of the universe has a name, the heat death. It is perhaps the most misleading name in all of science, because it sounds hot, and the universe in this state will be the coldest it has ever been. The heat death does not mean the universe burns up. It means the universe reaches a state of maximum entropy, a state where energy is so perfectly and uniformly distributed across space that no further useful work can ever be done. In thermodynamics, the science of heat and energy, useful work requires a difference, a temperature difference, a pressure difference, a concentration of energy in one place compared to another. When everything is perfectly uniform, when every region of space has exactly the same temperature, exactly the same energy density, there are no more differences. And without differences, nothing can happen. No reactions, no movements, no processes of any kind. The universe becomes, in the deepest possible sense, static. Not dead in the way a living thing dies, but frozen, unchanging, a perfect, infinite, cold stillness. It is the universe at rest, the universe at peace. After 100 trillion years of stars burning and trillions more of black holes slowly evaporating, the universe will arrive at this final state and remain there unchanged for the rest of eternity, which is, in a sense, a very long time indeed.
But here is the thought that I want to leave you with tonight, as you drift slowly towards sleep. The atoms in your body, every single one of them, were forged inside stars. The carbon in your cells was made in the cores of red giant stars that died billions of years before our sun was born. The oxygen in your lungs was scattered across space by ancient supernova explosions. The iron in your blood was created in the final moments of massive stars that collapsed under their own gravity. You are not separate from the universe. You are not an observer of it, looking at it from outside. You are made of it. You are a part of it. And in a very real sense, you are the universe's way of knowing itself. The stars burned for billions of years. They lived and died and scattered their material across the cosmos. And through an extraordinary chain of events, solar systems forming, planets cooling, chemistry becoming biology, biology becoming consciousness, some of that stellar material became you, became a mind that can look up at the night sky and feel wonder, that can lie in bed and think about the last star, that can feel the beauty of a universe so vast and so old and so patient. You are the universe's remembering what it was like to be a star. And that is not a small thing. That is perhaps the most extraordinary thing in all of creation. And so we come to the end of our journey tonight. We have traveled from the present moment, a universe blazing with 2 trillion galaxies and countless stars, all the way to the final darkness, where the last star quietly fades and the last black hole slowly evaporates, and the universe settles into its long, eternal rest. It is a journey across timescales so vast that our minds cannot truly hold them. But perhaps that is the point. Perhaps the universe is not meant to be understood. Perhaps it is meant to be felt. Felt as vast, felt as ancient, felt as patient and beautiful and indifferent in the way that only truly enormous things can be indifferent. And in that vastness, you, right here, right now, in this bed, in this moment, are something remarkable. You are alive in the age of stars. You exist in the brief and beautiful window of cosmic history when the universe is full of light, full of warmth, full of wonder. The last star is 1 trillion years away. Tonight, there are 100 billion stars in our galaxy alone, burning steadily in the darkness above you. The universe is alive, and you are alive inside it, and your body is made of the same ancient stellar material that has been cycling through the cosmos since the very beginning. Close your eyes now. Let your breath slow. Let the story settle around you like a warm blanket. The stars are burning tonight, and you are here to see them. And that is enough. That is more than enough. Sleep well.